So, thank you, Carson, and we'll switch over now to Volker.
Hi everyone. So my talk will be a bit more technical, but I really want to do it in a way that really everyone understands what I'm talking about. But the hope really is that you get an understanding on how those things also work. So it's about content addressing and also about distributing data and verifying things. So the goals for this talk is really that you learn about what content addressing is, so you can go back home and tell everyone what it is. And then, of course, like why it is useful and why, and also like talking about some applications of like that enable content addressing. But before I start, quickly about me. So I'm Volker, I'm based in Germany, and I've done open source geospatial things for over 15 years. So OSGeo, OGC, and all those things. I kind of started in the front end. You might know open layers, for example. And then later on databases, you might know GeoCouch. And then I also got into the whole like offline first, local first movement kind of things with Apache CouchDB. And then, I got into IPFS and I discovered that also like with IPFS and IPLD and such things, you can also build kind of like local first, offline first applications. And this is where I'm still interested in. And we see an example in the end. But now let's get into the details. So also important, the focus today is that I really want to focus on the concepts and not a specific technology stack. So although my background really is in IPFS, IPLD, Filecon, and so on, I don't want to basically reduce it to those technologies because there might be limitations. There might be things that might not work today, but could work in the future, or could work at all, or you need a totally different system. But I really want to focus on the technology because this is, I think, what enables so many cool things. And then we can later talk about is this possible with IPFS or not, and so on, if you like. But yeah, there's also many other content address-based stacks you could use. So content addressing. Before I get into what it is, I start with something else because we first need to talk about location addressing because like that's kind of like the counterpart to it, and that's something like all of you already know because like this is about like where is the data. And a good example is URLs. And I mean, the L in the URLs already suggests that it's about a location. So you really say, I want to have this website on a certain server in this kind of directory and this file. You type it into your browser and get there. But we all know the problems with it. The problems are things like you have a 404 not found. It's just gone. And you don't know where it's gone. Often, like, I guess we all know that, I don't know, like some companies or universities just like redo the website and it's still there, but you just don't know that it's still there because it moved somewhere. And you might be able to find it again, but yeah, it's just not obvious where to find it. And the other big problem is, and I think it's a really huge problem, which is underrated, is you send someone a link and say, well, read this article, it's really great. But then by the time that someone reads the article, you don't know if this person actually reads the same information that you have read. It could be replaced with something else. It could, of course, be malicious, but even then, there could be some update. It could, change things, but you don't know. So those are the problems about location addressing. And therefore, I advocate for content addressing. The switch is a bit difficult technologically, like from a tech perspective. So to make it easier for you, there's a great example I always use in these kind of talks is the library example. So to explain what means location versus content addressing. So in location addressing, I would say, oh, I've read this great book and you should read it as well. And then I tell you, okay, get this book. It's super easy. You just go to Augsburg where I live, go to the university, go to the library. It's the building down the hill on the second floor, the bookshelf on the third floor, the third book from the right. That's the book I'm talking about. And we can already see like this has the same problems as with the World Wide Web with the URLs. The book might not be there. It might be a different book. What is way easier and how we usually do it with books is I tell you the title, or even better, I tell you the ISBN number. And you can easily identify, oh, it's that book. And you don't even need to get it from the same location as I did. You can just buy it online, or you can get it from your library. And the other thing is what you also get with it is you get the verifiability that you actually got exactly this book that I read, because you can compare the ISBN number and say, oh yeah, we really read the same thing. So now how do you do this with technology? How do you really get like this kind of system running? Okay, so the core part about content addressing is hashing. You might know it from building checksums. So if you are geeky and have, for example, like downloaded your own Ubuntu ISO image to, like in the early days, put it on a CD-ROM or something, you might see something like in the second line is the like a mixture of like characters and letters, and then the file name. And this is what you usually use to say, well, what I've downloaded is really the thing that I wanted to download. So you build a hash, but like, what really is a hash? So I try to keep it simple. So you have some data somehow, and then you have a function. It's really like a mathematical function. You put something in and you get something out. And the output is just a long number. And how it actually works doesn't really matter what the function does. The important thing is if you put in the same input, so I put in my like geotiff from some area, I get some long number out. And if I put in exactly the same geotiff again, I get really the same number out. Or if you put it in or someone else puts it in, you get the same number out. That's the important thing. And now this is the part where it gets interesting. Almost certainly, unless there's a hash collision, which you usually try to prevent. So if you hear about hash collisions somehow, it's really a big problem. So you don't want to have those. But almost certainly, the point also is if you put in something else, you also get a different long number out. And I say almost certain because like this is kind of like the catch. Because like if you could map everything to a certain number, we would just use all those numbers in our everyday life. Like every one of each of us would have a number and be identified uniquely. Of course, like it's a limited space of, well, numbers are not limited, but in order to be practical, it's kind of limited. But the almost certain is so certain enough that it works for real world systems. And what I mean with it is usually like those big numbers are like 32 bytes, which if you don't know what I'm talking about, that's totally fine. But basically, it's really like a small number. You can just put it on the screen. But those numbers are so big that you could identify uniquely every atom on Earth with such a number and still have numbers left. So it's just big enough for practical systems. It's just you can be certain enough. And this is also what systems like IPFS say. It's certain, it works. We can basically map from a number to the data and from the data to the number again. And this then leads to, we can use those hashes, those long numbers as an identifier to really identify the content and be sure if something has the same number, it's actually the same content. So Carsten already mentioned it, so it was great that you had a short slide about it, because like content addressing is really about like which data is it and not where it is. It doesn't actually matter where it is. And what I'm mentioned about the problems about the location addressing is that, for example, if the data moves, if you really have like such an identifier and don't care where it is, it can be moved somewhere else. So again, think about the previous slide from Carsten. If you think about things, you have several servers and some servers down, it really doesn't matter because you can still find it because it's not really pinned to a location, but just like find it somewhere. And just as with the ISBN number, you can verify that the thing that you've downloaded, just build again like this hash, you use this hash function to build this long number. And if the long number matches to what you wanted, you know it's actually the same data. And this brings us to peer-to-peer networks. Again, like as yeah, with other tech stuff and peer-to-peer networks sometimes often have those things like, oh yeah, it's only like for public accessible data and kind of like those file sharing kind of things, like the older people in the audience might still might still remember the Napster story and so on, is think, oh, between networks, Napster, illegal stuff going on. But this doesn't have to be true. So you can also have, for example, a distributed network with internally, which well, I will also be talking about. And then the nice thing about those is I referred to before that yeah, you have multiple servers, they are equal and so on. No situation of failure. And yeah, again, like this whole like content addressing thing. The other point also is about data locality. So if you don't care where the data is, it could even be local. So let's say you are a research institution and your research is focused on satellite imagery in Southeast Asia. You might have a copy of the data locally available in your network. You might even share it with others, but you might also not, but still, you can have your data locally available. And then for every researcher in the institution, it's very fast to download and work with because you don't need to go to the open web and so on. That's just like have it locally available. And if they have their pipelines, they don't need to change their pipelines. So of course, like your pipelines to specify, well, it's this S3 bucket somewhere. And then if you run it locally, it's like, oh, like now I need to run some emulated S3 thing that kind of works like the way S3 works. No, if you really always work with those content identifiers, you can just run the same scripts and it doesn't matter if you download it from the internet or have it in your local network available. So now I come to the part from my huge long title of the talk about the data distribution. That's something I've been talking about for the past, I don't know, 6 years or so, because yeah. Fun story about this. So when I got into IPFS, I thought this would be ideal for distributing satellite imagery. So my goal was to convince, so my goal still is that convince the European Space Agency to use a peer-to-peer network to distribute the data. When I started it, and there are talks available, it was 6 years ago, I said my goal is within 10 years. So now I'm already like 6, 7 years in, so it's slowly getting close that I really need to deliver it, but I still try to. So what is this about? I was talking with someone like back then from the DLR, which is the German delegation of the European Space Agency. And I also have to say that because yeah, it's a story from back then. So I know that even the data distribution recently changed from the European Space Agency. So some of this might not be such a big problem as it used to be, but I'm just starting where it came from basically. So the data distribution worked back then like this. So they the German delegation downloaded the data through HTTP and then keeps a copy of those things. And then they store the data for a limited amount of data for a certain time. So again, I don't recall the exact dates, but let's say, for example, they say we store the whole world for all the data from the past year of the whole world. And then we store, let's say, the data of Europe for 2 years, and Germany, which we care about as a German delegation, we store those kind of data forever, basically, all the full archive. Now you have to think about in Europe, you have many delegations. So let's say France would do the same. What you end up with is you have for a short amount of time, you have an archive with like 10 copies of the whole world for 1 year, but then you're down to basically 1 copy after this. And so you have many duplicated data, but the problem is the people just don't know because like they have their own regulations, they have their own rules, they just make the copies as they see fit, but the others don't know. And if we get into the world of a peer-to-peer network, you could just know how many copies are there. And you can say, well, we need for this area of the world, we want to always have like 3 copies. But you don't care like who stores those 3 copies. So you could, for example, say, well, Germany stores the archive from 2022, France stores the archive from 2023. So basically, it would still use the same resources, but we have a way better overview of like which data is stored where, and yeah, we would be more resilient about like losing data. And this again is what I mentioned previously was here I'm really talking about really the internal data distribution between those delegations. So it could be a totally private network that is just used there and is not publicly available. Of course, like what I dream of is you expand it to an open network, but you don't really have to. It could be just like the internal distribution mechanism, and then you publish the data somewhere else or as you used to. And this really is, yeah, for me being just like more efficient and yeah, having a less error-prone system basically. And then to the other part about the verifiable data pipelines. So again, my example comes from the Copernicus Sentinel imagery, which is like similar to the Landsat data in the US. There we have like if you sell it into satellite imagery, you have like different levels of processing. So there is the level 2 data, which is kind of like the data basically, you know, when you look at the satellite imagery, this is what you think of like that satellite imagery. That's level 2 data. Before we get into level 2, there's level 1 data, which is kind of like more raw, and you need to process it to basically get those nice colors out and so on. And what is interesting that the cloud providers, like if we talk about AWS or Google or Azure, they have those level 2 data sets from a satellite imagery that you can then do your analysis on. But from them, from some I know for sure, from some I guess they did the same. They used the level 1 data and did their own processing pipeline. The problem is you don't really know what they actually did. Sometimes some publish what they did, sometimes they don't. The problem also is you have different outputs from the same data. So basically, if you download an image from the same area from the same time from AWS or from Google, it is kind of like the same image, but like in the details, it's different and you can't really tell. And even worse is what happens if the data was modified? You can't tell. Let's say, for example, you say, oh, like those, like someone says, well, yeah, we don't want to deal with like the deforestation that much. We just like take an image where the deforestation was less worse, and then we just put it into the pipeline and we get something out, and everyone who downloads it and does the analysis just gets the beautified, undeforested version of the image. If we would do something like content addressing, they couldn't get away with it because then, and this is what I basically dream of, is that you have a pipeline which is open source and you have those steps. And with each step, you could, oh, it's actually the next slide, I think. Yes, and with each step, you also publish the content addresses of the results. And so you basically have the full chain of results and the content addresses and so on. And then if you, for example, download for your area subset, you can verify yourself, yeah, it's actually the thing, I get the same result as the cloud provider did, for example. And then you do it for a small area and verify, yeah, it's the right thing. So you can probably assume, well, they did the same thing for the whole world. Obviously, you can't be sure, but the trust would be higher. And also, if then some third party provides data, yeah, you can also like verify that they actually did the thing they say they did, and not only trust them. So we get again into the trusting system, trust part, that you still need a bit of trust, but you need less trust. And I think that's better under those circumstances. And then real quick, because I have hardly any time left. So you all can also like, this is like kind of related, but I just want to say this project I currently work on, and is you can even scale down the whole like peer-to-peer distribution part to small devices. So what if you can just run a peer in your browser on your mobile device? You can then have a platform which does not need app stores. It works with, and I basically built a demo, a quick one, where you can basically run peer-to-peer replication of data from browser to browser between different operating systems, let's say from iOS to Android, and you don't need any server infrastructure. So it's really just like scanning QR codes and you are connected. You only need a Wi-Fi or like GSM. So what you really need is you need to be able to see each other's IP address for those who are deeper into it. And yeah, that's basically it. And my the use case would be, I see it in the disaster response use case where you really don't have any infrastructure. Spinning up a Wi-Fi is super easy if you don't need any like big servers there, but just like the Wi-Fi. All right, and that's it.
Thank you, Volker. We've got some time for questions. We've got about 10 minutes for questions, and then we'll stop for a coffee break.
In your example of a disaster response, can you elaborate a little bit more of how that would be?
Yes, okay, yeah. So so the idea would be so of course, like, okay, so let's say, yeah, there's these disaster, and then you have people out there mapping the damages, for example. Of course, like they of course need, for example, like the data from the area. So you would need some infrastructure for getting the initial data, but it could still be like at home or at some remote place where basically they start and they download the data on their phones and then have the data locally available. And then they go out in the field, make changes to the data. And at one point, they then can replicate the changes to the other ones. And all they would need to do is they need to be in the same Wi-Fi. So really practically, it would be you then meet at the end of the day, you have a Wi-Fi, everyone scans the QR code from each other, and then you click on replicate, and then everyone has the same data. And then someone else could, for example, like drive back to some central area where you have like proper backup, proper servers and so on, and replicate it again to this server, basically. Or someone drives in the evening to the server, replicates the data, gets the new updated data from someone else, and gets it back there. But the point is that really the from a like kind of like engineering perspective, you don't do something like so the data really is the same on the server as on your mobile device. So you don't have any, like many different layers of interaction between them, but you really just like, yeah, really keep the actual data around. And yeah, but we can also like, I'm happy to talk about this like for, I could talk about this like for hours. So
Generally, and Nori was using Raspberry Pi to deploy like cadastral data. So in case of a disaster where there is no centralized internet or something, basically folks can use Raspberry Pi to have their own local instance to broadcast data to others who then use it on their mobile device. So it's like data distribution or information distribution.
yes. And of course, like only because you don't need server infrastructure, you could of course also like have infrastructure like in Raspberry Pi. Like it's just maybe it's the extreme case that you can even serve, but usually yeah, you just deploy a Raspberry Pi and go with this. Yeah.
So for like this disaster example, and the person gets back to the central place, the data is somehow replicating between browsers. Is that example like the data is meant to be open to anyone who can join replicating it, or how do you think of like data access control and that stuff?
I actually haven't thought about data access control at all yet because it was just like a fun prototype. So yeah, yeah, yeah.
Do you see a lot of database solutions, like if you say, for example, sending out for emergency manager data, they all inject they all in one.
Yeah. Yeah, so of course, like so the problem with replication always is what happens if you have a conflict and someone kind of like did a similar thing. And this is what like back in the days, CouchDB solved quite well, I think. And I would do something similar. So again, we come to the point about content addressing. So if really someone really made the exact same change, like really exactly the same down to the byte, it won't be a problem because it's the same content identifier again. So this is easy. But if it's like slightly different, let's say you've put in like a comma in the end or something, then of course we get the data. This is kind of like what I think like would need to be solved on, or like there's a lot of research going on solving this problem of different data automatically. And I think sometimes it's possible, but I would say most of the time what I would do is it's really application specific. So for example, like in the disaster response case, for example, I think you just would display, oh, we have two entries doing the same thing. A human needs to decide like what's the correct thing. In other cases, you might not care. For example, like if you say you collect data and you might just use the like people are someone is counting how many people were there. You would just use the highest number, for example. Then you can basically automatically resolve it. But I think that's really like application specific. So I think it's a layer on top, yeah, really in the application and not on the lowest level where I'm like working.
Yeah, just a few thoughts on that. Years ago, I was led the commercialization effort for something called GeoGate, which was the Git library for geospatial, so the distributed version control. You can always do lots of versions. The challenge is putting everything back together again. So setting that aside though for a second, this is something that I think as an organization, like content addressing in the form of a satellite image makes a lot of sense. That's a cohesive, logical bucket of bits. What we suffer from in the vector world, in my opinion, one of the missing pieces is we have no metadata structure at the feature level. Our current metadata constructs are all at the data set level. And until we understand things at the object or feature level, we'll never really be able to content address an object, right? There's no logical structure around what that is. And I really feel like the first thing we've got to really do is, and this is something I would love to see OGC kind of lean into, is like, how do we figure out how to move into a metadata model where we can identify objects in a data set? And that way you can deconflict. If your two teams out measuring fire damage overlap by a little bit, 90% of their data set may be different, but 10% might overlap. And we would never really know that if we look at it at the data set level. Anyway, I can go on for days about this.
We should.
Thanks for the very good presentation. I agree with with your concept on complex addressing. I think what I think is one more benefit of complex addressing is also to certify that the copy is the original, or the copy is the right. The copy is the original, right? Yeah. So which is extremely important from the point of view of distributed databases. So that's one point. And just practical question. You mentioned that this is your idea how this can work. Did you run any specific demonstration trials, anything technical that you actually try to implement some of those ideas?
Yeah. So it's just basically what I describe is basically what IPFS is doing. So IPFS, the interplanetary file system, is doing that, or could be used, but it could be used today for the data distribution if you would like to. So, but I haven't run any trials but that's, well, yeah, so.
Have you seen CART, the guys in New Zealand, the coordinates people, they're doing the best like distributed versioning using Git right now, where it would be like, I could see that stack on IPFS, like actually.
I actually haven't, so I have, so basically I met the founder like in 2009 at the G, so I should probably talk to them about it. Yeah, so
yeah,
I think it's for the point. Yeah,
it's like actually pretty robust.
Yeah, they're pretty good people. So yeah, so yeah.
Oh, sorry.
Oh, sorry, I went at the front. Sorry.
Yeah.
Yeah.
I don't know much time left.
We'll do one last quick one and then we'll go to coffee break and then keep chatting.
Okay, yeah, I think this short. So they implant the data from different sources, and then afterwards they realize that there is some like a duplicate. And then what do you do? And then how can you identify which source they want to connect this data from?
Yeah, this is kind of like the same problems to be with the data collection in these cluster response use cases. That so if the data is, if then it's the same, then it's no problem because it's the same identifier. But if it's slightly different, I would say again, like some human needs to decide which it is. So because like what you also always want to do is you want to attach to those content addresses, which is really just like as I said, like a long number, some identifier. You want to attach a human name to it, which is a totally different problem, a huge one, but still. And if you have two things and attach the same, have something the same name, the same human name on it, and a different identifier, a human should just check like which one do I want to use, or do I want to merge them, do I want to pick one, and so on. But I think that's thing a human has to do.
Perfect, all right. So we've got some time now for a coffee break, and we do have name tags up at the front, because I know we had some folks join later. We did a round of introductions, but nobody can remember all those names